Hello, welcome to APES screencast for the energy pyramid, or energetics of ecosystems. Here's a picture we saw in class at the end of our last lecture, which we talked about NPP, which is the net primary productivity of ecosystems measured in kilocalories, so the energy captured in calories, per meter squared, so a square meter of the Earth's surface, and this is calculated on a per year basis. So our most productive ecosystems on here can be seen in red, and the least productive in the darker blue areas. These black areas are where there are no data. And so you can see, like the deserts, as you might expect, pretty low productivity down here in Australia as well. But our open oceans are pretty much very low in terms of net primary productivity. But let's not forget that because of the vast size and scale of our oceans, most of the photosynthetic processes producing our oxygen and capturing our energy in terms of carbohydrates are from the oceans. So while it has a very low NPP, its overall energy capture is probably the highest of all ecosystems. What's also nice to point out, you would expect the high latitudes, so the top and the bottom areas of the globe here, to be very low productivity because photosynthesis requires sunlight, and sunlight in some of these areas is less than 80 to 60 days a year. But these are very productive ecosystems. Take a look at the coastlines of Antarctica. Some very productive ecosystems there. Also look at North America, where land meets ocean. We have very, very productive ecosystems in our high latitudes, in addition to just about all coastal zones of oceans. So they are sometimes known as our tropical rainforests of the sea, for example, coral reefs, because your productivity is so high. Especially take a look here at the western side of South America. This is going to be important later. Very, very productive ecosystem, high NPP. Well, you might guess that tropical rainforests have the highest of all NPPs. Don't forget that in front of those are wetlands. So these could be saltwater, freshwater wetlands, estuaries, bogs, and so on. Wetlands have an extremely high NPP. And some of our most endangered ecosystems fall under this category, in addition to coral reefs and tropical rainforests. So in terms of just energetics, our most productive in terms of NPP ecosystems are quite endangered. So let's talk about energetics, and as you know, all energy begins with the sun. So let's go ahead and change my pen color to red. We'll draw energy today in red. So our nearest star, full of hydrogen and going through fusion, sends us electromagnetic energy, and some of that is visible light, and that gets captured in our ecosystems. So I'm going to change my pointer here to black. And an ecosystem, captures that energy and transfers it through the food web or the food chain. So there's different parts of a food web or food chain. You may think about the old school, little fish gets eaten by big fish, and all the way up the food chain you go. But all ecosystems begin with producers, green plants primarily, capturing that sunlight energy, and they get eaten by herbivores, or what we call primary consumers, and they get eaten by secondary consumers, and ultimately tertiary consumers, and sometimes you find ecosystems with quaternary or higher consumption. Now, this pyramid is in the shape of a pyramid for a reason, because as energy goes up and gets transformed, the second law of thermodynamics says you lose some quality, and we lose it here as heat to the environment. So there's a one-way flow